So, Heaven, uh, your own is me Deepak. So, here's the architect's confession that is the nightmare I bought when I chose database sharding. I have learned that sharding is splitting a massive database into smaller, manageable pieces. Isn't a solution to scaling, it's a one way ticket to complexity hell. Every senior developer and architect talks about sharding as the ultimate solution, but they conveniently forget to mention the immediate crippling that it introduces. My recent deep dive into data partitioning proved that the moment you choose sharding, you trade a simple operational problem for a host of distributed system nightmares. Here are some of them. The first is the cost of partitioning. So what does this mean? Is the trading uh, input output for cognitive load. So the purpose of sharding is to reduce the input output load on a single server. It works, but the cost is brutal. Let's say, for example, a simple SQL query is there. It becomes the architectural problem. It's just a simple query. Let's say if my Spring Boot service needs to perform a join or aggregation across all user data, it can no longer hit one server. It must now query 10 or different shards, run the aggregation on each one, and then combine the results. It's a huge, hugely complex and slow process that's known as scatter gather. That's the query killer. And the it can also be, let's say what happens when a business process like transferring money or checking inventory requires updating two different shards. We reintroduce the exact consistency problem we solved by having a single database. We are forced back to complex, slow, and expensive distributed transactions like the Saga pattern just to do basic data operations because it's now in the multiple shards. Is the unavoidable cross shard transaction. And the second point I want to discuss is that the data locality and the hotspots. So what does this mean is that they say that is the theoretical simplicity of sharding breaks down instantly when you introduce a real world traffic patterns. So let's say for example if a shard based on a user's ID but on a single user, example for let's say a high volume bot or a celebrity who generates 80% of the traffic. So that single shard becomes a hotspot, completely bottlenecking the entire system. Your 10 server sharding solution is now effectively running on one server. That means is the whole lot of overload onto that specific particular shard itself is the hot shard problem, which is a big issue we need to look into. And the second is, let's say, uh, we shard to improve latency for our React users globally. But now we have to deal with data sovereignty laws and the PSLC trade-off. That PSLC is the extension of the cap theorem, where the partitions are involved in the distributed systems. Is here at the global level. Should the data for users in France be stored locally, but introduces immense consistency overhead with the US shard? So it should not be the case. That is geologically also it's a very painful thing. So because sharding forces this brutal compromise over here. And the third point which I want to discuss about the our discussion point, that is the complexity, that is the unsung complexity of resharding. So the most terrifying moment in a sharded system's life cycle is when the initial sharding key proves wrong or the volume demands splitting the existing shards as well. So is the resharding trauma. This is an operational war. You must live migrate petabytes of data from the existing shards to the new splitted shards, all while the system is under full production load. So this requires complex custom tooling and introduces massive risk of data corruption or prolonged downtime. It's an admission that the initial architectural decision was fundamentally flawed. So is the solution which that came into my mind is that the Web3 solution. This is where the blockchain's design philosophy is generally superior. So the systems like Polkadot uses parachains or sharding methods that are baked into the protocol, managing the coordination and security of state transitions mathematically. We are trying to solve a distributed coordination problem with SQL that Web3 is solving with cryptography. That might be a good solution, which I thought about. So here's the is what everything that I learned, that the decision to shard is the moment you commit to becoming a distributed systems expert. So if you don't fully understand the operational and consistency costs, you should not touch it. and I spend more time thinking about the resharding strategy than the initial schema. So my current task is developing a framework to automatically detect and alert on hot shards in a production cluster based on input output matrix and the transaction volume. So I want to ask to you that what is the single most effective metric or technique you have used to predict when a relational database will hit its IO limit, that is input output limit, and require sharding before the customer complaints start?